Okay, in this lecture, we're going to study Chapter 6, Discounted Cash Flow Valuation. And we're going to continue our study of time value of money that we have learned in the previous lecture. So let's recall time value of money. So on the timeline, earlier money is called present value, and later money is called future value. And in the last lecture, we have learned, given a single cash flow, let's say earlier money, we have learned how to find its future value. So the future value is present value times 1 plus r to the tth, or given future value, we have learned how to find its present value. So the present value is future value divided by 1 plus r to the tth. Okay? And in this lecture, we're going to extend the concept of time value of money to multiple cash flows. So after studying this chapter, we want to be able to determine the future and present value of investments with multiple cash flows. So let's look at specific examples. Okay. Suppose you invest $500 in a mutual fund today. So you invest $500 in a mutual fund today and $600 in 1 year. If you want to know if the fund pays 9% annually, how much will you have in 2 years? In other words, you want to know the future value of your investment, of these cash flows. So we can apply the future value formula that we have learned in the previous lecture to a single cash flow. So the future value of this $500 is $500 times 1 plus interest rate is 9%, it's 0.09 squared because you have to compound twice to get here. And also we can apply future value formula to this $600. So the future value is 600 times 1 plus 0.09. Okay, so you compound it only once. And they are in same currencies, so they are in dollars in 2 years. So they are in same currencies, so we can add them together, find the future value. Okay. So if we add them up, the future value is $1,248.05. Okay. So that's the future value of these two cash flows. How about the present value? So let's look at the next example. So you're considering investment that will pay you $1,000 in 1 year and $2,000 in 2 years and $3,000 in 3 years. Okay. So if you want to earn 10% on your money, how much would you be willing to pay for this investment opportunity today? Okay. So this example is asking, what is the present value of these three cash flows? So similarly, we can apply the present value formula for single cash flow to each of these cash flows separately. So the present value of this $1,000 is 1,000 over 1 plus 10%, so 0.1. Okay. And the present value of this $2,000 is 2,000 over 1 plus 0.1 squared, because we have to discount this twice. And the present value of this $3,000 is 3,000 over 1 plus 0.1 cubed, because we have to discount this 3 times. So they are all in same currencies. So they are in dollars today, in today's dollars. So we can add them together to find the present value of these 3 cash flows. So if we add them together, we have $4,815.93. So that is the present value of these cash flows. So let's generalize this idea to any arbitrary cash flows. So the rule is simple. First, we can use the present value formula for single cash flow for each cash flow separately. Then we can add them together to get the present value of the entire cash flow stream. So that's the general present value formula for multiple cash flows. Okay. This will apply to any type of cash flows, but in this chapter, we're going to look at some special types of cash flows. So we're going to look at annuities in this lecture. Annuities are a stream of identical cash flows that occur over a finite horizon. So the two keywords here are identical and finite horizon. Okay. So these cash flows, C1, C2, C3, all the way to CT, are all identical. So C1, C2, all the way to CT is identical. So we can drop the time subscript. Okay, just call all these cash flows just C. Okay, so it's finite, so it ends at some point. So this type of cash flows are called annuity. So annuities are very common in practice. So here are some examples. So regular deposit in a savings account. So you save $100 every month for the next 10 years. So that's regular deposit in savings account. So that's an example of annuity. Also, car loan payments or student loan payments and mortgage payments are all examples of annuity. So annuities are pretty common. So it's really important to understand annuities very well. So when we have annuities, this general formula can be simplified. Okay, let's see this. So the present value here is C over 1 plus R. We can drop the time subscript because cash flows are identical. So C over 1 plus R squared plus all the way to C over 1 plus R to T. So that's just the general formula. So let's call this equation number 1. And I'm going to multiply both sides of this equation by 1 plus R. Okay. So 1 plus R PV is equal to C plus C over 1 plus R plus all the way to C plus 1 plus R to the power of T minus 1. Okay. So I multiply through this, the first equation by 1 plus R. So let's call this equation number 2. And then I'm going to subtract the first equation from the second equation. So equation 2 minus 1. Then so this minus this is R times PV. That's on the left side. On the right side, so this will cancel with this. And this will also cancel. And this will also cancel. All that's going to remain is C minus this. C over 1 plus R to T. Okay. So we can collect these two terms here. C times 1 minus 1 over 1 plus R to T. Okay. So that is R times PV. So the present value of annuity, so that is equal to C over R times 1 minus 1 over 1 plus R to T. Okay. So that is the present value of annuity formula. So when we have identical cash flows, when we have annuities, this general formula can be simplified to this. Okay. Okay, let's look at some examples. So after carefully going over your budget, you have determined that you can afford to pay $632 per month toward a new car. And you call up your local bank and find out that the going rate is 1% per month for 48 months. So you're looking into the car loans. So you have determined that you can afford to pay $632 per month. Okay. And you can take out a 4-year loan. So you want to know how much you can borrow. Okay. So that is essentially asking what is the present value of these cash flows. Okay. So we can find the present value of these cash flows in 2 different ways. The first, using the general formula. So we can use this general formula. This should work for any type of cash flows. So we can use the general formula to find the present value of these cash flows. 362 over 1 plus the interest rate is 1%, so 0.01. So that's the present value of this, plus 632 over 1 plus 0.01 squared. So that is this. So you discount it twice. And with a little patience, you can go all the way to here. 632 over 1 plus 0.01 to the power of 48. So as you can imagine, this is pretty tedious. Okay? But fortunately for us, when we have annuities, when we have equal cash flows, and we have this shortcut. Okay, so we're going to use this shortcut here. So alternatively, we can find present value using the present value of annuity formula. So 362 over 0.01 times 1 minus 1 over 1 plus 0.01 raised to the power of 48. Okay. Which is equal to $24,000. So that's how much you can borrow if you can afford to pay $632 per month for 48 months at interest rate of 1% per month to buy your car. As you can see here in this example, this formula is very useful. And the present value of annuity formula can be applied in many different situations. So if you look at this equation, you see that there are 4 variables. So present value, C, which is a payment, R, which is interest rate, and T. Okay. So there are 4 variables in this equation. That means that if you know any 3 of these variables, then you can find out the 4th variable. So in this example, you figured out the present value given the rest of the variables. Okay. And in different situations, you may be interested in finding out different variables. Let's look at more examples. So the next example, suppose you want to borrow $28,848 for your car. So that's how much you need to buy your new car, and you can borrow at 9% per year compounded monthly. So what that means is that the interest rate, you have to make monthly interest payments, and monthly interest rate is 9% divided by 12. So 0.75% per month. So that is your interest rate. So if you take the 6-year loan, you want to know what is your monthly payment. Okay. So let's draw a timeline. I'm gonna make some space here. Okay, so it's important to draw a timeline. Okay, so you want to figure out your monthly payment. On a 6-year loan, so the end date is 72 months. Okay, so you want to borrow $28,848. So that's going to be the present value of your monthly payments of these cash flows. Okay, and so that interest rate is given here, and number of the payments, the period is given here, that is T. So we can use present value of annuity formula to find out the monthly payment. So let's set up the equation. So 28,848 is equal to monthly payment C over R is 0.0075, which is 0.75%, times 1 minus 1 over 1 plus 0.0075 with the power of 72. Okay. And the C is the unknown in this equation. So we can solve this equation for C. Okay, so let's do this. So that is so this is 55.48. So 28,848 is equal to C times 55.48. So you can solve for C, then you're going to get $520. So that's going to be your monthly payment. Okay? Payment on this particular loan. Okay, let's look at a different situation, which you may see quite often. So suppose you ran a little short on your spring break vacation, so you put $1,000 on your credit card, and you can afford only the minimum payment of $20 per month. Sounds familiar, right? So the interest rate on your credit card is 18% per year, compounded monthly. So you make monthly interest payments on your credit card. So you want to know how long will you need to pay off this $1,000. Okay. So let's set up the timeline to better understand this example. Okay. So you have credit card balance of $1,000, and you make the minimum payment of $20 every month. And you want to know how long you're going to have to make this payment on your credit card balance. Okay, assuming that you make no further purchases on your credit card. So your credit card balance is the present value here, and the interest rate is 18% divided by 12, which is 1.5% per month. So that's interest rate, and your monthly payment is C, cash flow. So you want to know T, okay? You want to find the number of payments or number of periods. Okay, so you can set up the present value of annuity formula. So the present value is 1,000, that is equal to 20 over 0.015, 1.5%, times 1 minus 1 over 1 plus 0.015 to the t's, okay? So t is the unknown here, okay? In this equation, we can solve this equation for t. Okay, let's do this step by step. So let's do this first. So 20 over 0.015, that is equal to 1333.33, okay? So that is equal to 1,000. Okay. Next, we can get rid of this by dividing both sides by 1333.33. So that goes away. And this is 0.75 1 minus 1 over 1.015 to the teeth. Okay. So if you subtract 1 from both sides, you get negative 0.25 is equal to negative 1 over 1.015 to the teeth. Okay, so again, get rid of this negative sign on both sides. So 0.25 is 1 over 4. So we can do the cross multiplication. So that is equal to 1.015 to the teeth is equal to 4. So that is this times this. Okay. So the t is in the exponent. So we can take logs to knock this off, right? So the t is equal to log of 4 over log of 1.015. Okay, so that is equal to 93.11 months. Okay. So if you make the minimum payments on your credit card, then it's going to take 93.11 months to pay off your balance. Okay. Okay, so let's look at the next example. So this will illustrate the different situation. So suppose you borrow $10,000 from your parents to buy a car, and you agree to pay $207.58 per month for 60 months. So you're curious whether your parents are charging you fairly, so whether your parents are charging you less than what your local neighborhood banks will be charging you. So you will know the monthly interest rate implied in the loan from your parents. Okay. So let's make some space. Okay, let's draw a timeline first. So you make monthly payments of $207.58 every month all the way to 60 months. And you borrowed $10,000. Okay, so that's your present value. And your monthly payment is this, that is C, and 60 months is the T. Okay, so you want to know the interest rate. So let's first set up the equation. So 10,000 is equal to 207.58 divided by R, which is the unknown, times 1 minus 1 over 1 plus R raised to the power of 60s. Okay, so you want to solve for R. But unfortunately, the R is here and here. Okay, so we cannot really solve this analytically. So we have to use the trial and error process. Okay, let me illustrate how this thing works. So let's see here. It's going to work similar to guess my numbers game. So guess my number game. So you may know about this game. So it's going to work like this. So I'm going to play this game with you. So I'm thinking of a number between 1 and 10. I'm thinking of a number which I won't tell you. Your job is to guess my number. Okay. Number is an integer number between 1 and 10. So you're going to make a guess. So your first guess is 5, which is a reasonable guess. Then I tell you whether your guess is correct. And if your guess is incorrect, then I tell you whether your guess is too high or too low. And I tell you where your guess is too low. Okay. Then, based on this information, you can revise your guess and make a second guess. So 5 is too low means that 1 to 5 is not my number. So my number has to be between 6 to 10. Based on this updating of information, you make your second guess. So you may guess 8. Okay, and so forth until you guess my number correctly. Okay, I tell you whether your guess is correct, or when your guess is incorrect, I tell you whether it's too low or too high, and based on that, you update your guess. Okay. So finding the interest rate works the same way. So you have to first make a guess. Okay. So it'll be easier on the multiple choice questions. So here are my choices. And I'm going to make my first guess. Okay, I'm going to pick the number which is in the middle, okay, which is our optimal strategy. So, and I compute the present value at 1% interest. Okay. So at 1%, the present value of this guy at 1%, so 7.58 over 0.01 times 1 minus 1 over 1.1 plus 1 plus 0.01 raised to the power of 60th. Okay, and I compute this present value at 1%. Okay, then I get $93.32. Okay, then I compare this to what the present value should be, which is $10,000. So my guess is incorrect, right? This present value of annuity formula tells me that my guess is incorrect. Actually, my guess is too low. The present value is too low. That means that the interest rate, my guess, is too high because R is in the denominator. So the present value and interest rate, they move in opposite directions. So if the present value is too low, that means that my interest rate guess is too high. So I'm going to have to revise my guess down. Okay, so let's go back to my choices. So that is incorrect, and that is too high. That means, okay, these choices will go away. Okay, I can narrow it down to these two choices. Then I make my second guess. So my second guess is 0.75%. Okay, then add this 0.75%. So at this 0.75%, I compute my present value to 7.58 over 0.0075 times 1 minus 1 over 1 plus 0.0075 to the 60th. Okay, and that is $10,000. So my guess is correct. Okay, so that is equal to this. Okay, so that tells me that my guess is correct. So interest rate, monthly rate is 0.75%. Okay. So let's summarize this process. So to find the interest rate, you have to use a trial and error process. So first you have to choose interest rate and compute the present value of the payments based on this rate. And you compare the computed present value with the actual amount. And if the computed present value is greater than the actual loan amount, then the interest rate is too low. And if the computed present value is less than the actual loan amount, then the interest rate is too high. And you adjust the rate and repeat the process until the computed present value and the loan amount are equal. Okay. So far in this lecture, we've seen how to use the present value of an annuity formula. What about the future value? So suppose, let's look at this example. Suppose you begin saving for your retirement by depositing $2,000 per year in an IRA. If the interest rate is 7.5% per year, then the question is, how much will you have in 40 years? Okay. So you make some regular deposits like this, $2,000 each year in your retirement savings account for 40 years. Then you're curious, how much will you have in your account after 40 years, right? So that should be the future value of these cash flows. Okay. So in this lecture, we learned the present value of an annuity formula. And in the previous lecture, we learned the future value formula of a single cash flow. The future value is present value times 1 plus R to T. Okay. So if we combine this, then the future value of annuity is, okay, the present value times 1 plus R to the T. Then which will simplify to C over R times 1 plus R to the T minus 1. Okay. So that is future value of a annuity formula. Okay, so let's apply this formula to find out the future value of your savings. Okay, so if the interest rate is 7.5% per year, so that's R, then you want to know how much will you have in 40 years. Okay, so the future value is 2,000, which is the annual payment, over R, which is 0.075, 7.5%, times 1 plus 0.075, raised to the power of 40 minus 1. Okay, so that is the future value of this cash flow, which is equal to $454,513. Okay, so that's how much you will have in 40 years. Okay, so this is what all I want to talk about in this lecture. So thank you for watching, and I will see you next class.